Hello. Now we're going to continue our work with finding the equation of a circle, and we're going to use an algebraic method this time for trying to find that equation. So what I mean by that is we're going to take the equation of the circle, so our x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. We're going to take these 2 points and sub in their x and y values. That's going to give us 2 equations involving g, f, and c. And then we're going to use the fact that we have this line containing the center. Well, what does that mean? It means that minus g and minus f are the coordinates of a point on this line. The center of the circle is at minus g minus f, and that's a point on this line. So that gives me 3 equations for my 3 unknowns, and I'm going to use them using simultaneous equations. I'm going to find out the values of g, f, and c, and that gives me the equation of the circle. So this is a perfectly valid method. The reason I tend to advise you towards the geometry method is because by drawing a picture, you can anchor yourself in what you're doing. This is fairly abstract, and it's quite difficult to spot if we make a mistake. But sometimes it's the best option. And one of the reasons it can be a good option is going to come up while we're doing this question. It's if we have some constants equal to 0, like we've got a 0 as one of our coefficients. Sorry, we've got a 0 as one of our numbers here, and we've got 0 constant in my line equation. That's going to speed up this kind of method. So if we see 0, 0, say, as one of the points on our circle, this type of method will often be quicker. But let's jump into it and put it into practice. So I'm going to take my point A. I'm going to sub those values of x and y into my circle equation so that I'm just left with an equation involving g, f, and c. So I end up with 2 squared plus 0 squared plus 2g times 2 plus 2f times 0 plus c is equal to 0. Now you can see if we had a point on our circle that was at 0, 0, we'd immediately get the value of c would be 0. So that's one of the reasons why if we have a point on the circle that's 0, 0, this can be a faster method, because we can immediately get c. Now, working this out, I end up with 4 plus 4g plus c is equal to 0. And to turn this into the form that we usually have our simultaneous equations in, I'm going to subtract 4 from both sides so that I end up with 4g plus c is equal to minus 4. That's just to turn it into the form where we have letters on one side and numbers on the other that we'd often use with simultaneous equations. Next point, we have b is at 3 minus 3. That's also a point on the circle. That means it solves this equation. This value of x and y solves this equation. So I have x and y. And I sub in again and I get 3 squared plus minus 3 squared plus 2g times 3 plus 2f times minus 3 plus c is equal to 0. I multiply that out and I get my 9 plus 9 plus 6g minus 6f plus c is equal to 0. And I can tidy that up a little bit and subtract 18 from both sides. And I get 6g minus 6f plus c is equal to minus 18. And then I'm going to go to my straight line. So I know I have my line here, my line k, 2x plus y is equal to 0. And I know that the center of my circle is on this line. My line goes through the center of the circle. That means that the center of the circle, which we know from our formula tables is at minus g minus f, this point is on this line. So these coordinates, this x and y value, solve this equation. So I can sub that in, and I get 2 times minus g plus minus f is equal to 0. The fact that there's no constant in this equation does something very nice for me, because I now have an equation in terms of only g and f. What does that mean? It means I can rearrange this, add f to both sides, so I know that f is equal to minus 2 times g without any addition or any other complicated bits. This means that I can just do a substitution, which is a faster way of doing my simultaneous equations. So as I'm doing lots of simultaneous equations, I'm going to label my equations. I'm going to call this equation 1, this equation 2, and this equation 3. And I am going to, what do I want to end up with? I have an equation here in G and C, and I have an equation here in G, F, and C, and I have an equation here that relates F and G together. So what I'm going to do is sub this value for f, minus 2g, into this equation. That will give me an equation only involving g and c, and then I can do simultaneous equations with g and c to get the values that I need. So I'm going to sub equation 3 into equation 2. Write yourself little notes like this to describe what it is you're doing, because if you get muddled in these kind of questions, there's so much algebra going on, it's very easy to get confused, and it can be quite difficult to get back on track. So we're subbing in minus 6 on minus 2g plus c is equal to minus 18. So I have 6g plus 12g plus c is equal to minus 18. So 18g plus c is equal to minus 18. I now have an equation, I'll call this equation 4, which is an equation that only involves g and c. I have another equation that only involves g and c, so now I can do simultaneous equations on these. And fortunately, I have very easy simultaneous equations because I have a plus c here and a plus c here. So if I subtract away equation 1 away from equation 4, equation 1 minus equation 4, I should say, minus equation 1, I'm going to cancel out my c's and I'll just be left with an equation involving g. So minus equation 1, this is equation 4, so minus equation 1 is going to be minus 4g minus c is equal to 4. I add these two equations together and I get 14g is equal to minus 14. Therefore g is equal to minus 1. Sorry, divide both sides by 14. And g is equal to minus 1. And now I just go back through the process of finding what f is. I know that f is equal to, so equation 3 tells me that f is equal to minus 2g. Therefore f is equal to minus 2 on minus 1. So f is equal to 2. And then going back to find the value of c. I know that 4g plus c is equal to minus 4. Let's do that. 4g plus c is equal to minus 4. Well, g is equal to minus 1. This is equation 1. So I have 4 on minus 1 plus c is equal to minus 4. Therefore, c is equal to 0. If I add 4 to both sides, c is equal to 0. So then, subbing back in to get my equation of my circle, I have my value for f, my value for g, and my value for c. So I have x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. Subbing in, I have x squared plus y squared plus 2 on minus 1 x plus 2 on 2y plus 0 is equal to 0. X squared plus y squared minus 2x plus 4y is equal to 0. And that is the equation of my circle. So we can see how this works out, and it doesn't really matter what information they give us. We're going to be able to form 3 equations involving g, f, and c, and we're going to do simultaneous equations of one flavor or another, and we're going to use them to find the values of g, f, and c and sub them back into our equation formula. And that is how we use our algebra method. And again, it's more difficult to keep track of what you're doing, but it is faster if we end up with nice situations like this, where we have a line that goes through 0, 0, or one of our points goes through 0, 0. In those types of cases, this can be a little bit faster. So that's what we need for the algebraic method of finding the equation of a circle.